Hi Dan, thanks for your question. Today we're going to be solving for a variable x given the diameter of a circle and a line tangent to the circle. To solve for x here, I'm going to use the rule that a line tangent to the circle is always perpendicular to the radius of the circle where it meets the circle. So I'm going to go ahead and draw the radius in here, tangent to the circle. Draw the radius in, and this is a 90-degree angle right here. I'm also going to use the rule that the diameter of the circle is twice the radius. So if d is the diameter, then d is 2r. But d in this case is given to us. D is 3x. So 3x is equal to 2r. Solving for r, I have that r is equal to 3x over 2. So I'm going to go ahead and put those values in on my circle. 3x over 2. We have the radius of the circle here, and we have the radius of the circle here. And we have that this value up here for this line is equal to 10. That's given to us in the problem. It looks like I have a right triangle now, so I'm actually going to use that triangle to solve for x. So I'm going to take it out of the circle and draw it over here so I can see what's going on a little better in the problem. I'm not a very good artist, so bear with me. I'm going to write in the values for the legs of the triangle. Here I have 3x over 2, and on the larger leg I have 10. And for the hypotenuse of the triangle, I have 3x over 2, which is the value from here to here. And I also have a value of x added on to that. So the whole thing has a value of 3x over 2 plus x. So given a right triangle, I can solve for the legs in this triangle or the hypotenuse of this triangle using the Pythagorean theorem, which says that a squared plus b squared is equal to c squared, or one leg squared plus the other leg squared should give you the hypotenuse squared. So I'm going to go ahead and insert those values into the Pythagorean theorem. Here I have the first leg, which I'll call a, so 3x over 2 squared plus 10 squared is the distance on the other leg, equals 3x over 2 plus x squared. I can now simplify this and start solving for x. So my first step is to simplify the problem. I'm going to go ahead and distribute that exponent through my product there. So that becomes 9x squared plus 10 squared is 100. And then, following the order of operations, I'm going to simplify what's inside my brackets or parentheses before I take the exponent into account. So 3x over 2 plus x is the same as 3x over 2 plus 2x over 2, which is equal to 5x over 2. So I have 5 over 2x squared on this side of the equation. Simplifying again, I have 9x squared plus 100 is equal to 25 fourths x squared. I have x squared terms on both sides of this equation, and my goal is to solve for x. So I'm going to start grouping my terms that have x's in them on one side and my terms that don't have x's in them on the other side. So since I have an x term on my left side, I'm going to go ahead and put it on my right side. So I have 100 is equal to 25 over 4 x squared minus 9/4 x squared. I can simplify again here. 25/4 x squared minus 9/4 x squared will give us 16/4 x squared. 16/4 is of course just 4. So I have 100 is equal to 4x squared. I can then solve for x squared, and dividing by 4 on both sides, I have 100 over 4 is equal to x squared. So over here, I'm going to continue the problem. I have 25 is equal to x squared. Now usually when we solve for x here, if we take a square root, we would have to add an additional plus and minus in front of the square root, but you don't need to do that in this case because we're dealing with a distance. So you can just solve for the positive value. Taking the square root of both sides, I have that the square root of 25 is 5, and the square root of x squared is x. And that is your final value for x. So thank you very much for your question. I hope this has been helpful, and I look forward to answering more of your questions using SnapMath in the future.